Do you remember the graph of quadratic function? Yes, that we have studied in the quadratic equation chapter. If you remember that, then this lecture will be very easy for you. So in this lecture, we are going to discuss about how to solve quadratic inequalities. So hello, my name is Shyam Manawat and I welcome all of you to this lecture. Let's get started. Now here you have example of quadratic inequalities. You should take help of the quadratic functions graph to understand quadratic inequality. It will be easy. Let me give you a walkthrough of this. Here we have learned that the quadratic functions graph look like parabola. You have vertex here, which is a minimum point. It grows it's open at one direction. Yeah, so either upside or down. Yeah, it's going up or it's going down. How do you decide, or how do you check whether it has to go up or it has to go down? By looking at the coefficient of x square, right? Coefficient of x square. So if x square coefficient, the general form of quadratic function is what? Ax square plus bx plus c equal to f of x. So if you look at a, and if a is positive, you see towards up. If you look at a as negative, then you see the parabola downwards. Yeah, what is a? The coefficient of x square, right? And here they meet this x-axis, this point, at the expression, the quadratic expression equal to 0. That means when f of x or y is equal to 0. Yeah. So taking reference of this, now let's solve inequalities, quadratic inequalities. So this is equal to 0. Now this is question number 1. So I am going to go in details of each and every step. So please do not skip any part of this video if you want to understand quadratic inequality. Now if I take this quadratic expression, which is x square minus 10x plus 24 equal to f of x. In that case, you know it's going to get me a parabola which is upwards this way, because the coefficient of x square is positive. It's 1, it's positive. And here these points will be the roots of quadratic expression. That means if you put f of x, that means this axis is f of x. Here, if you put this equal to 0, the values of x, the roots you get, that will be on the x-axis. Yeah. I hope I don't have to go in details of how to plot the graph. For that, if you don't know that, if you don't remember that, please go through quadratic equation lecture, and here lecture number 1, 2, 3, 4, 5, 6. Yes, 6th lecture. Please go through that. There I have gone in details of quadratic functions graph. So please go through that. Here I'll keep it little shorter. Finding the roots. Now I have discussed the shortcut of finding the roots also in quadratic equation. Please go through lecture number 2. You will understand how to find out with the shortcut. Okay, so 24, if you need to find out two numbers which multiplication is 24 and addition is 10. In fact, minus 10. So let's see first 10 and then we'll make it minus. Now here we have 4 6 24. 4 plus 6 is 10. How to make it minus 10? When you say minus 4 plus minus 6, you make it minus 10, right? So looking at that, what should be your roots? Roots should be, you simply just change the sign of these two values, 4 and 6. These are the roots. Yeah, that is by using the shortcut to solve the quadratic equation. We have discussed this in detail, guys. I hope I don't have to get into details of this. What do? We find two numbers, which product is the constant term. So 4 6 are 24. We need 10. So here 4 plus 6 is 10, but I want minus 10. So for minus 10, I make it minus 4 minus 6. The moment you get this number, which is giving you product as the constant, the sum as coefficient of x, the middle term. You have these numbers and then change the sign and then write directly here. That's the roots. Yeah, that's a shorter way to find the roots. Well, once you get the roots, then I want to see that on the graph. Once you get the roots, what do you do next? You have graph here. Yes. Somewhere here you will find 4, somewhere here you will find 7, and graph will be something like this. Oh, yes, it should be something like this. Please don't mind my drawing skills. I know I'm not very good at that. Come on, yaar. Come on. Okay. Man lo, it's good. Let's assume this is a perfect parabola. Yeah. Okay, so this is what? This is your f of x, or you can also call this to be y-axis. Here, this is your x-axis, right? Now, the quadratic inequality which is given to us is this one. Let me take this for you here down. And for the same quadratic function, we got this graph. Now tell me one thing. Instead of 0, when we have f of x, we got this graph. That means this entire expression is, if I take it as f of x or y, this means the given inequality means f of x to be more than 0. More than 0 means positive. Now here, this point is origin. Yeah, understand this, understand, then I will tell you the shortcut also. Understand. This point is origin, and we are looking for all the values of function which are more than 0. That means we are looking for the points on this graph which are for more than 0, like these points, right? Now these points you will get when you take the values of x less than 4 or more than 7, isn't it? Less than 4 or more than 7. Are you getting it? Yeah. So what should be answer for this? Answer for this should be, this will get you more than 0 when you take x less than 4 or more than 6. No, why am I writing 7 here? Yeah, that's 6. My bad. Don't get confused. Huh? My bad. 4 and 6. So I am writing. I need to plot it on the x-axis. Yes. Less than 4 or more than 6. Here. Fine. Okay. Great. Okay. I hope you got this point. Now tell me one thing. If the same expression, which is what, x square. Oh, I have copied that, so why not I paste it directly here. Yes, the same expression, instead of more than 0, what will be the solution if it is less than 0? What is the solution if this is less than 0? Less than 0. So what do you do? In that case, if I take the reference of the graph 6 and 4, assume that this is a correct graph. Okay, yes, it will look like, it will definitely look like this, something like this, right? And if here this expression is less than 0, that means what, to draw the graph we have taken this expression x square minus 10x plus 24 as equal to f of x, or you can say y also, either one of them. Understand, this axis is for the dependent variable, which is either y, or you can also say f of x, either one of them. Do not get confused here. Now if I have done that, that means here this inequality means f of x is less than 0. Do you agree with me? F of x is less than 0. That means I need to consider all the points which are less than this origin, less than the x-axis, right? That means here are the points, correct? Now these points you will get when you have x more than 4 and less than 6. Yeah, more than 4 and less than 6. So here you will get x more than 4 and less than 6 because you have common values possible here. Yeah, so or shall I write it like and less than 6. See the difference. And is the conjunction, or is the conjunction. Do not get confused with this and or. Yeah, you need to understand why it's and, why it's or, because all these points are possible at less than 4 or more than 6, because I can't say and, I can't use and because there is no common values possible which is less than 4 as well as more than 6. Not possible, right? No real value will satisfy this. No single real value will satisfy this, right? Okay. Yes. So after looking at this graph, do you agree with me that whenever this expression for a to be positive, whenever this expression ax square plus bx plus c, this expression which will always have graph something like this, yeah, considering a is positive, considering a is positive, for this expression to be more than 0, if it is more than 0, understand this, if it is more than 0, then it is always going to be above the x-axis. That means it is always going to be less than, the x value will be less than the smaller root here or more than the greater root here. Think about it. Here it was 4 and 6. So for the expression to be more than 0, we had x less than 4, smaller root. More than 6, 6 is a greater root. Yeah, do you agree that? Do you agree with that? Yeah, so can I say for expression to be more than 0, x value will be more than the greater root? Note it down. Note this, this is important. Or less than smaller root. Yeah? Yeah, once more. Yes, get once more. For the graph of f of x, which is a quadratic function, the graph will look like parabola. And instead this, if I have case 2, note this, case 2, yeah, note this down, ax square plus bx plus c expression, if it is less than 0, that means below the origin, then we will have only these points on the graph. That means the x value will be more than the smaller root and less than the greater root. The x value will be more than smaller root and, because you have common solution, common values possible between them, right, and less than greater root. Yes, if you understand here what I am talking about, then you don't have to draw the graph all the time. Yes, yeah, with this, so I hope you have noted case 1 and case 2. Hey guys, are you using pen and paper or not while watching these videos? If not, then please go and pick up pen and paper and then watch this video. Make your own handwritten notes, solve it by yourself, otherwise you are not going to learn. Take it from me, you are not going to learn. Just don't watch these videos, make handwritten notes, and trust me, it will be very helpful to you when at the last minute of, during the last minutes of exam, you will be able to revise it faster because it's your own notes, nobody else's notes. Don't take any other people's handwritten notes. I have seen many institutes promoting that, okay, handwritten notes. You make your own handwritten notes. Yeah. Why do we have to take other people handed notes. Yes, refer it to those notes, but by referring to those notes, you must make your own handwritten notes. Yeah, and later you can give it to me so I can pass on to the next students. Okay, joke apart. Okay, now let's look at this case. The expression ax square plus bx plus c, this expression, the function, is more than 0. This case belongs to, check which case, this belongs to which case, the case number 1, yeah, where we are going to consider case number 1 more than 0. Yes, let me draw a line here, because this graph is for case 2. Case 1, yeah. So once we get the roots, how do you get the roots? By making it equal to 0. X will be more than the greater root or smaller than the smaller root, yeah, by looking at the graph. Yeah, so can we directly jump on to the conclusion? Let me find out the roots here. 36 here, 36. Tell me the numbers. Question 2, tell me the numbers which can get you product as 36 and subtraction as 9. Okay, yes, 12 3s are 36 and the subtraction is 9. How do you get 9? Plus 9, 12 plus 12 minus 3. So root should be minus 12 plus 3. Yes, shortcut. Now, the answer is, if the expression is more than 0, then x will be more than greater root or smaller than smaller root. That's your answer. अभी और कितना शॉर्ट बताओ यार, और कितना शॉर्टकट यार. Come on guys, इससे ज़्यादा शॉर्टकट और क्या होगा? You got the quadratic inequality and you got the answer. You know the shorter way to get the roots by looking at the graph, understanding case 1 and case 2. You understood what happened if the expression is more than 0, if expression is less than 0. Yeah. Okay, that's the answer. You want to try one more question? Fine, you have one more question. Yeah, a few more questions for you. Yes. Okay, pause this video, look at the question and tell me the answer first. What's the answer? Okay, fine. Okay, first of all, to apply that case 1, case 2, yeah, this graph, what did I say? A has to be positive. Here, do you find A, which is coefficient of x squared, do you find that to be positive? No. What do you do in that case? You take all these expressions to the other side. You get x square positive minus 3x minus 4, instead of plus 4 it will become minus 4. Now simplify this. What you have here, simplify this. 4 ones are 4 and after subtraction you get 3, but you want minus 3, so it should be minus 4 plus 1 to get minus 3, so that the roots will be what? Minus 1 plus 4. Change the sign. Instead of minus 4 it will be plus 4, instead of plus 1 it will be minus 1. Then you get the roots. Once you get the roots, you understand. Now this expression, don't look at the original equation now, original question now, the the inequality of the question, because we come to this root after taking the expression all to the right hand side. By doing so, this expression become greater than 0. So we are going to apply the condition for greater than 0. In case of expression being more than 0, we have the values of x, which is lesser than the smaller root or greater than the greater root. Yes, that's your answer. This is your answer. Yeah. If you are not understanding what I'm talking about here, why greater than, smaller than this, then please refer to this part of video where I'm explaining the graph again and how do we come to this conclusion for case 1 and case 2. Yeah, revise this. Do you understand? Make A positive if it is not positive and then apply. Okay. Yes, one more question. Try this. Pause the video. Try this by yourself. Try this by yourself. Yeah, I know the challenge. You can't find the roots for this. You can't find the real roots for this, because this expression, if you put it equal to 0, x square minus x plus 1, if you put it equal to 0, then this is going to get you imaginary roots. Yeah, imaginary root. That means this, if you make it, now for imaginary roots also, please, for imaginary roots also, please, you know how to, how to draw the graph, you know that. See, for imaginary roots also, we have discussed how to draw the graph. For imaginary roots also, we understood the, when the roots are imaginary, then the parabola does not touch x-axis. You know that. All right, you know that. Okay. So again, coming back to this, A, ultimately it will be parabola, right? So we need to see whether it is upside or downside. Now here you see the coefficient of x square, which is A, is positive. That is positive. So it's going to be upside, right? It's not going to touch x-axis, right? It's going to be above the origin, above the x-axis. That means no matter what happens, it will never go below x-axis. That means no matter which value you put, which real number you put at the place of x, you are always going to get this to be more than 0. More than 0. Whereas the given question, are you getting the point? X square minus x plus 1 equal to f of x. Whatever you substitute at the place of x, you are always going to get the value of f of x more than 0, because it will only follow the points which are above the origin. Are you able to connect the dots? Let me tell you which concepts do you need to understand this. First, how to plot the graph of quadratic function. Second, understand the graph of quadratic function when the roots are imaginary. Yeah. Third is here, that now you have this expression, given expression, which will always be positive, given as it has to be negative, less than 0. That means it has to be negative. Negative values are less than 0, right? Tell me one thing, is it possible? It's not possible. This f of x here, f of x, having f of x less than 0 is not possible, because f of x is always going to be positive. For to be negative f of x here, negative f of x, the graph has to go below x-axis, which is not possible, because the equation here, this equation here has imaginary roots. Yes, that's why we will say here, we will say, see guys, if you are not going to follow all the lectures in series and you skip some part of that and then you watch it, then it will be difficult for you. Okay, if you find my teaching pace to be slower, please increase the video speed. Simple, increase the video speed, no problem, but don't skip. Yeah, because you don't know where are you going to find the concept which I am going to use it in the next lecture. Nevertheless, so here it's not possible, so we will say what? No solution possible, no solution possible, no solution possible. Yeah, okay. Now same, here you got more than 0, the solution is possible. What did we understand? This entire entire expression, if you put it equal to f of x and try to plot the graph, you are going to get the graph look like this, where here f of x will always be above origin, is never going to be negative. It's always going to be positive. So always going to be positive. That means it will always be positive no matter what value of x you substitute, right? So you will say this x belongs to all real roots plus infinite to minus infinite. You substitute any value, it will satisfy all the values. Yeah, this is the answer. Yeah, did you understand? When you get the roots, then what to do? If you have the roots imaginary, then what to do in quadratic inequalities? Yes, please rewind this video. If not, rewind this video. Okay, I got another question for you, a beautiful question. It's more than second order equation. It's a cubical equation, third order equation. How do you simplify that? Of course, you need to have the graph. Yeah. Now, let me make you understand. If it is, it's like 2x plus 1 equal to y or f of x. Let me take f of x here. It will be a linear graph, straight lines. That means it's going to pass x-axis maximum one time. It's going to have some, if you put f of x is equal to 0, it's going to have some value of x. That means it will touch the x-axis, passes the x-axis only once. If you have quadratic, x square minus 5x plus 6 equal to 0, quadratic or equal to f of x, then it's going to touch the x-axis twice, here and here, twice. If you have quadratic like this, yeah, x cube minus, let me take this, let me copy this for you. Let's say this is equal to f of x, and then you look at the graph. Now tell me how many times it should touch the x-axis. Of course, the number of values you get when you substitute f of x, of course, when you substitute f of x is equal to 0, the number of values you are going to get for x, the graph will touch x-axis those many times. Shall I repeat this for you? When you substitute f of x is equal to 0 here for quadratic function, then you get two roots, two values of x. That means it should touch the x-axis 2 times. If it is cubical, then it will touch x-axis 3 times because you get 3 values of x, third order. We have solved these cubical equations in quadratic equation chapter, the last chapter of quadratic equation, the concept builder video. If you have not gone through that, please go through it again, request, please. Yeah, that means the graph will be something like this, yeah, or like this, but we need to make the graph at least touching axis 3 times if you have 3 values of x when you substitute f of x is equal to 0. Are you able to understand this? Are you able to relate the first order equation graph, second order equation graph and third order equation graph? When you substitute f of x is equal to 0, then how many values of x do you get? Those many points, those many times the graph passes through x-axis. Clear? Okay. Now why graph is important? Because here it is inequality. So first we need to find out the roots, and then we need to understand the graph. Now I am not going to solve this cubical equation. This I will leave it for you because we have solved a couple of them in quadratic equation. Here, see, here we have solved cubical equation. Yeah. Okay, and we have discussed some of the shortcuts also there. So please go through that. Let me write the roots for you here. So when you simplify this, you will get roots as -1, 1, and 5 cube 5 cube 5 yes 5, right? Yes, that means the graph is going to, let me draw the graph. The challenge is, I'll tell you the challenge also. So -1 here, -1, you got 1 here, +1, and you got 5 here. The challenge is, I need to understand whether this is starting from down and then going up, or in this case also it touches the x-axis 3 times, right? Or think about it, or starting from up and then it's going like down. Which one is correct? Because both of them are going to get you different answer. Yes, so better off, we can go into more technicality of this and understand how to generalize, but keep it simple, guys. They are not going to ask you difficult mathematics. They just want to understand whether you can apply the logic and get the answer or not. Yeah. So when I say this is equal to f of x, yeah, this is equal to f of x here. This is what we are solving. So what do? I know that one point is -1, one point is +1, one point is 5. Now I will see the value of f of x, whether it is positive or it is negative, for the range with less than -1, between -1 and 1, between 1 and 5, and more than 5. And then you will be able to draw, or you will be able to understand what should be the solution. Let me do it for you. Let me see, for this part, the function is showing less than 0 or more than 0. This part means here I can take -2. If I substitute -2, it will get you -2 for x is equal to -2. Look at this, for x is equal to -2. Yeah, because here you got the range, you got the range. Less than -1, you got the segment. Less than -1, between -1 and 1, between 1 and 5, and more than 5. Yeah, x is less than -1, x is between -1 and between -1 and 1, then x is between 1 and 5, then x is more than 5. Okay, so I will check for each of these range, and then we'll finally come to the conclusion, because ultimately we want this f of x to be what? The expression to be what? More than 0, more than or equal to 0. So look at this. Look at this. More than equal to 0 se yaad aaya, here also we had somewhere equal to 0, but I used equal to 0 in the answer or not? Equal to, more than, more, less than, more than. Yeah, here we had equal to. Let me correct this for you. We had equal to also, so use equal to sign also. Use equal to sign also. Correction. Use equal to sign also. Okay, same thing here. Yeah. Try the range. Substitute x is equal to -2. So for -2 you have what? -2 cube is -8. -5 into -2 square will be +4. +4 into 5 will be -20. -2 minus x is +2 plus 5. See what you get here? -28. Yeah, -28 plus 7 is definitely going to be less than 0. Yeah, so here function is what? The expression is what? This expression is what? Less than 0 for x is equal to -2. So it should definitely start from down and then going up, and then has to come down, and to meet again has to come up. That means, understood? So this is first thing you need to identify. Then you got the answer, because you want the function, this expression to be positive. So positive it is possible for f of x above x-axis, So this will have above x-axis value between -1 to 1 and then later more than 5. Yeah. So answer, are you getting this? Because see, if you see between 1 to 5, here the graph is going below origin, below x-axis. So this for here you will get f of x less than 0, negative f of x, because it is below x-axis, here f of x will be negative. Are you getting it? So here you got the answer that f of x, the x will be between -1 to 1 for f of x to be positive and more than 5 for f of x to be positive. Here, this one and this one. Yeah. So the answer is f x more than -1 less than 1, or not and, because you don't have any single common number which satisfy more than 5 as well as less than -1, less than 1. Yeah. So this is your answer. This entire, yes, you are right, this entire thing is your answer. Okay. Yeah, you want to see in terms of set, how will it look like with using bracket? It will be from -1 to 1, and because question said it's equal sign, question has equal sign also here, greater than equal to, I will take equal sign here also. Okay. Now because they are equal, so I am going to use a close bracket here. Yeah, union, or a close bracket for 5, and it will go more than 5 till infinite, but infinite is never equal to infinite. So for infinite it will always be open bracket. For infinite it is always an open bracket. Okay. So please revise this part of this question. Please revise this question. We have discussed a lot of things here. Please revise this question. Yeah. And let me not make this lecture longer. Let's cut short here. So this is it in today's video. Now next lecture we are going to discuss some LOD2 and exam past year papers. Yeah, in inequality. So I will see you in the next lecture. Oh no, we have one more concept builder. Fine, we got concept builder here. Yes, so we are going to solve inequalities with 2 variables in the next lecture. Fine. Okay, so this is it in today's lecture. My name is Shah Manava, signing off. I will see you in the next video. Till then, stay happy, stay healthy. Bye bye.